Hi and Assalamualaikum. My name is Aiman Fatina binti Mat Kamal. Okay, today we will present our group presentation, which is high voltage engineering. Okay, our title is 132 kV polymeric insulator. Okay, alternate shade. Okay, so we are from group 2, section 4. Okay, my group consists of 5 group members, which is the first one is me, Aiman Fatina binti Muhammad Kamal. Okay, my matrix number is DE200094. And then Ahmad Sofi, okay, AE190061. And then Anas, okay, CE200109. And then Farhanis Nabila, okay, CE190237. And then Haniza Shahira, which is DE200909.
Hi, Assalamualaikum. My name is Haniza Shahira binti Arman. I will present about the introduction of this project. Who are us? Vote Swim was established since in early 2013, were led by IR Aiman Fatina. Specialists in high voltage engineering were expert in designing, developing, manufacturing, and supplier of the high voltage insulator that had been used in the transmission lines. Focusing in a safety while developing the technology in high voltage and sustainability of the insulator to produce the high quality system to make the environment and maintenance friendly factor. Project background needs to design, construct, and test the conceptual model of high voltage suspension types of insulator to prevent the leakage current from the conductor to the earth in the transmission system. Material that been used to design the insulation of high voltage. The objective for this project is to design the overhead line insulator extra high voltage line to simulate the performance of design by using the FEA software.
Okay, so for our problem statement is, okay, insulators play a crucial role in supporting overhead line conductor and preventing current from passing through the tower. Okay, so glass, ceramic, and polymeric material are commonly used for insulator production. Okay, glass and ceramic insulators have a high electric strength but are heavy but brittle, increasing the likelihood to break and cracking. Okay, the need of lightweight and flexible alternative has led to the proposal of polymeric insulator. Okay, polymeric are lightweight, flexible, and less prone to damage compared to ceramic and glass. Okay, so polymeric insulator has gained popularity due to their superior performance and cost effectiveness. Okay, the main objective of this study is to provide and propose the required specific for the design of polymeric insulator. Okay, for the methodology, we will review on existing insulator, and then we will propose a new design, and then we will run the design, okay, electric field test on the design using FEMM software, okay, and then we will compare and analyze the electrical field result for dry, wet, and contaminated test, okay. So the technical summary of chosen concept design. Okay, we will choose this polymeric, but the alternative state, the shade. Okay, so this distance, the fume phase distance is 330 mm, and this is 150 mm. Okay, the fume phase starts from here to here. Okay, same goes to here, which is 2,900 mm. Okay, this distance is 1,350 mm. Okay, so this design is using the AutoCAD, and then this one is using the SolidWorks. Okay, this is the explode version of the insulator. Okay, which is, we have the fitting over here, which is, this is the ball, and this is the socket, and this is the rod. Okay, which is, this is the polymeric. Okay, actually this whole this is connected all. Okay, so we have 1, 2, 3, 4, 5 shades of big shade polymeric, and then 4 smaller polymeric. Okay, so the total shade for this project is 9. So this is the 3D design of the polymeric insulator. Okay, we have the 9 shades. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is the ball and this is the socket. Okay, these also have been designed using the SolidWorks. Okay, so the parameters, okay, so our nominal voltage is 132 kV, and then rated voltage is 145 kV, and then our type option is long rod, and our material is polymeric, and our fitting type are ball and socket, and then our type of shade is alternative small and large, and then weather shade material is polyethylene, and then pollution level is 2, which is medium, and then the minimum cream page distance is 20 mm per kV. Okay, conductors is there 175 mm square, and then the cream page is 330 mm. The disc distance is 150 mm. The number of discs and shades is 9. Okay, minimum length is 1350 mm, and then the total length including the end fitting is 1500 mm, and the total cream page distance is 2900 mm. The biggest shade diameter is 200 280 mm, and the small shade diameter is 140 mm. The thickness of the shade is 20 mm. So this is the technical summary of FES simulation. Okay, first we will want to predict how a product reacts to real world force and other physical effects, and then use the simulation software, which is the finite element magnetic method, FEMM, and then examine the electric potential and field distribution, and then create 2D design in the simulation software. And then we will run 3 different conditions, which is one is the dry test, second is the wet test, and the last one is the continuated test. Okay, next Amma will show the simulation. Okay, thank you very much.
My name is Omar Sofi Bezamjad Arifin, matrix number AE190061, and I'll be presenting for the simulation and result. So this is how our design for insulator looks like, which is consists of 2 different line of shed, and this is on the normal condition. This we have three condition. Which is the first one is normal condition, second one is in wet condition, and the third one is contaminated condition. So for the normal condition, the graph for voltage looks like this due to it will gradually decreasing due to from high voltage to ground. And for the field intensity, it will looks like this. There is disturbance along the insulator road, while for wet condition we put water at 20 Celsius on top of every shed. And for the simulation, the result will be like this. It will gradually decreasing, but it's not smooth due to water that located on top of shade. And for the field intensity, it will looks like this. This is due to the wet condition. This we can see from its field intensity figure like this. While for contaminated condition, we put the water, and on top of water we put cement, which is located on top of the insulator shade. And then for the result, for the voltage, it is also gradually decreasing, but it is not smooth due to the cement and water. While for the field intensity, as you can see that the disturbance of field intensity is large due to the cement and water that we have put. So we can look at its field intensity figure, which is looks like this. That's all from result and design. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Anas Muhammad Ali. My number is CE 200109. Now I will be explaining about the partial discharge test. Okay, so partial discharge test is to find out the strength of an insulator when there is fault occur, which high voltage is applied to the insulator. Okay, so to find out whether it can sustain the high voltage. Okay, so first of all, we need to do preparation before we start any test, as usual. So the first thing we need is the personal protective equipment like glove, goggle, safety shoes, and other safety personal equipment. And next is the tools to test the insulator. And finally, before the testing start, we need to isolate the isolator to make sure it is safe and ourselves is safe. And next is to set up the testing part. Okay, the source is connected to the coupling capacitor and the isolator is connected at the other end of the coupling capacitor. And the partial discharge detector is connected to a measurement system to measure the frequency and other stuff. And after that, for the voltage source application at the insulator, it is required to be increased gradually so that it doesn't affect the insulator. So after the voltage is set at the amount we want, we should observe the system, the measurement at the measurement system, such as the frequency and magnitude of the isolator. And throughout the testing, you must make sure the voltage is stable so that the voltage, the isolator is not damaged. And finally, after finish taking the result, the voltage is to be reduced gradually to not damage the isolator from receiving potential damage. Next is we want to test the isolator with different voltage value. So just repeat the step at the voltage application until voltage reduction based on the voltage value that wanted to be tested on the isolator. Okay, that's all from me. Thank you very much.
Hi, Assalamualaikum. My name is Farah Anis Nabila binti Shariful Bahri. My matrix number is CE180237. I will explain about the conclusions of the project. The multiple tests on the prototype insulator were required to ensure that the planned insulator will endure 10 years. The electric field testing is necessary to determine the insulator critical point. An insulator critical point is located where the electric field intensity is high. When the electric field intensity is high, has a high potential to break down. High voltage testing is also necessary to determine whether the insulator can handle high voltage stress. If this insulator cannot withstand with high voltage testing, that means is not suitable for use in industry. That's all. Thank you.
Okay, that's all from our group. Okay, thank you very much.